All right, let's talk about one of those moments where science fiction basically just becomes science fact. We're talking about a massive breakthrough at the crossroads of artificial intelligence and biology, one that could completely redefine medicine. For the better, but maybe for the worse. So here's the headline. In 2024, for the very first time, researchers at Stanford University used AI to design and, get this, build a brand new functional virus completely from scratch. I mean, think about that. This isn't about just finding a virus in nature anymore. This is about creating one, literally going from a digital blueprint on a computer to a living thing.
Okay, to really wrap your head around how huge this is, we've got to talk about the field this all belongs to, which is called synthetic biology. You can think of it like this. Traditional biology is all about studying what nature has already made, right? While synthetic biology is about becoming the architect. It's about designing and building totally new biological systems that have never existed before. It's basically engineering, but your building blocks are DNA.
So that's the big question, isn't it? If you can actually engineer with DNA, how does that even work? How do you take a line of code on a computer screen and turn it into something that's, alive and functions in the real world? Well, it turns out the process is this really cool mix of digital AI smarts and hands-on lab work. It's kind of like this four-step dance between the computer and the lab. So first, you've got the AI. It gets trained on these just massive data sets of DNA, RNA, all that good stuff. It's basically learning the language of life itself. Then, once it's smart enough, it starts generating totally new viral genomes. These are the digital blueprints. Step 3 is where it gets really wild. Scientists take that digital code from the AI and physically synthesize it in the lab. And finally, they test it. Does this thing we just made actually work like a virus?
Now, you might hear this next part and think it doesn't sound great. Out of all the designs the AI came up with, only about 5% of them actually worked. 5%? But here's the thing, that's not a failure, it's actually a huge success. Because what it proves is that the AI isn't just randomly guessing, it's actually starting to develop a real predictive understanding of how biology works. And that is the whole game changer.
And that ability, the power to truly design biology instead of just hoping to discover it, well, that's the whole key. This isn't just some clever lab experiment. We're talking about a tool that has the potential to completely, and I mean completely, revolutionize medicine as we know it.
Just think about the speed for a second. The old way of doing things, finding a useful virus in nature, that could take you months, sometimes even years of searching. With AI, we're talking about a timeline that's now crunched down to a matter of weeks. We are fundamentally shifting from the slow, painstaking process of discovery to the super fast, super precise world of design.
So, what does this new power actually let us do? Well, imagine designing custom viruses, they're called phages, that literally hunt down and kill those scary antibiotic-resistant superbugs. Or how about this? The next time a pandemic hits, imagine developing and testing a vaccine in weeks, not years. This tech also opens the door to incredibly targeted gene therapies for genetic disorders, or even creating whole new types of medicines. The potential here is it's immense.
And whenever there's this much potential on the table, the money is sure to follow. Because of all these incredible applications in healthcare, farming, you name it, the synthetic biology market is on track to hit a staggering $85 billion by 2030. That's a huge economic engine that's pushing this tech forward at an absolutely breakneck pace. But there's always a but, isn't there? Every powerful new tool has a dark side. For all of its incredible promise, the power to design life from scratch comes with some enormous risks. It's the classic dual-use problem, right? A technology that's designed to save lives could, in the wrong hands, just as easily be turned into a weapon.
And that forces us to ask a really, really important question. When we have the power to engineer life itself, what could possibly go wrong?
Well, the concerns really fall into a few main categories. You've got biosecurity. That's the terrifying idea that someone could deliberately create a dangerous new bug. Then there's biosafety. That's the risk of an accidental release from a lab, with who knows what consequences. We already talked about the dual-use problem. And then there's a big one, equity. Are these amazing, life-saving breakthroughs only going to be for the wealthy, making the gap between rich and poor nations even wider?
And this really gets to the heart of the matter. This isn't a problem that scientists can just solve by themselves in a lab. It's going to take this incredibly delicate balancing act from everyone, from the researchers to the people making the laws and even the public. We have to weigh this amazing innovation against the absolute non-negotiable need for public safety.
So, how do we do that? How do we find that balance? How do we get all the good stuff from this technology while protecting ourselves from the bad? The only way we move forward is with a really clear, responsible plan.
Look, everyone has a part to play here. The scientists, they need to focus on safer research designs and be totally open about what they're doing. The policymakers, they've got to create smart, strong regulations and, this is key, work together across the globe. Because let's be real, a virus doesn't care about borders. And yes, that includes us, the public. We have a role too, to get informed, to talk about this stuff, and to hold our leaders and institutions accountable.
At the end of the day, the answer isn't to just try and stop innovation. I mean, that genie is well and truly out of the bottle. So the goal isn't to stop it, it's to steer it. We have to guide this incredible new power with wisdom, with foresight, and with a really clear idea of the kind of future we're trying to build.
So yeah, we have officially crossed a major threshold. AI can now engineer life. The big question is no longer if we can do this, the question now is how we choose to do it. How do we all, together, make sure this new power is used to engineer a future that's safer, healthier, and fairer for everyone? That's the challenge.